Hello, I'm Darren Jackal. I'm in my studio. I talk about product development, design, and mountaineering. Welcome to another episode of Experimental Design, Discourse, and Disclosure. Last few episodes I've been talking about my winter shelter called From the Road. And at this point in time, I think before we get into any more details about the specifics of the construction, we should talk a little bit about how to find a good campsite when you are mountaineering. So site selection and site preparation are critical to a good night in the mountains. This tent was designed for camping up high in the alpine, so above tree line, most likely on a glacier or on an ice field. So first thing you want to know about where you're going to camp is there something above me, overhead danger, that will fall on me and kill me? So I want to be aware of slopes above me that may avalanche. There may be seracs, and serac fall would be a concern, or rock fall. So these are major concerns that I want to think about when I'm finding a campsite. Another important consideration is wind direction. In the Rockies here of Canada, the prevailing winds will be from the west. So I want to make sure I set up my tent in a position where I can best manage the winds. The other types of winds I'm going to be experiencing during my time up there will be diurnal winds associated with heating and cooling during the day. These will be kadiabatic and adiabatic winds. Also, probably some localized winds from features in the alpine coming around mountains, being in the lee or in the windward side of things. So these are considerations that must be taken into account. Another thing you want to find is the proper snow to build your campsite on. The best snow is really solid snow that you could build an igloo out of. If you can't find this snow, then it's important to know how to manage other types of snow. So we may get into this a little more, but for now, site selection and site preparation are mainly concerned with danger and wind and snow. One other thing, I forgot to mention that if you're going to be up high in the alpine, camping on ice fields and glaciers, is that you do not want to build your camp on top of a crevasse. So this will be part of site selection and site preparation, is probing the area around where you want to place your tent and making sure that there is solid snow at least 2 meters deep, but you're not on top of any openings. From here, we'll go and take a look at the specifics of the tent. In design, we talk about two-dimensional things as being shapes and three-dimensional things as being forms. So the first part of this tent is its hexagonal shape, and we'll see that the hexagon is a very interesting shape and it's quite good at shedding wind loads. So we'll talk about that, and the other part of it is the form. Something like a pyramid or a teepee shape really helps with also wind and snow loading. So we'll talk about that in the next section. Once you find an appropriate campsite, you have to prepare it. Excavating the snow to create the various platforms also creates snow blocks for building snow walls to deflect the wind. I'm going to use the term shape and form interchangeably as one would in a conversation, just to make things easier. The shelter has inherent properties related to both its hexagonal shape as well as its pyramidal or teepee form that enables it to be extremely stable in the wind. I've said that the shelter is structurally a center pole tent, but it's the form of the shelter that gives it the stability. First is the hexagonal shape. On Saturn's north and south poles, the wind is racing at 1,800 kilometers an hour, and surprisingly, this system stabilizes into a hexagon. The 6 sides of a hexagon allow forces such as wind pressure to be spread out more evenly compared to other shapes. The even distribution of forces across the sides of a hexagon reduces the likelihood of stress concentration at corners or edges, making the structure more resistant to buckling or failure under wind loads. The tent is symmetrical and splits the wind, where it then rejoins itself on the lee side with the same equal pressure, and this reduces flapping. It's important to remember that a tent of this type is completely dependent upon the anchors that stakes it out. the anchors must be bomb-proof to keep the tent from blowing away. If we look at the canopy in cross-section, we see that it diminishes in size as it rises in height. This means the wind blowing across the top doesn't actually encounter much surface area, and the wind can easily be deflected. The tent has 6 sides, however, it has 3 main structural seams and anchor points. These seams are sewn in a catenary curve, and this is critical to minimizing flapping in the wind. And this brings me to another critical feature in creating a stable structure, and that is the guy lines. 6 anchors hold the canopy to the ground, and there are additional guy lines that occur halfway up the 3 main seams, and 2 sets of guy lines that support the doors at their tops, as well as another set on either side of the doors lower down. The center pole and boiler are subject to bending and buckling forces, and this is countered by the smaller upper poles being held together with plates. But the more important guy lines connect the structural elbow to the main seams at half chord. This is transferred through the canopy and terminates in bomb-proof anchors in the snow. This really helps the center pole inside the tent and reduces buckling forces considerably. And this brings us back to our structural elbow and why it looks the way it does. And in the next part of this, we'll talk more about the structural elbow itself and see how it has evolved to where it is and where I plan on taking it. Right, before I get on to the specifics of these things, let's talk a little bit about snow load, which I forgot. So anyways, shape like this, which sort of diminishes towards the top, does not have a lot of surface area at its peak for snow to actually accumulate. So what's going to happen is snow is going to land here and sort of flow down and perhaps build back up in this area. So what you need to do is on these sides, besides the doors, is you cut a little bit of a trench, and that way when snow starts to pile up, it's got somewhere to go if you bash on the side of the tent and let it fall down into these moats, and then you just clean it out in the morning. So in conclusion, this tent is really quite good at both snow loads and wind loads if you set it up properly, have good solid anchors, and use the guy lines as they are required. So on to the next part of the video, and then I'll wrap it up. As I was saying before, environment changed from being just hot gases from a liquid fuel stove to very hot gases in a wood stove that caused this one to melt. But you can see what's going on here. I've got my structure figured out a little bit, and I've got these components that are going to help tie it into the canopy. Once that melted out, I went to this version, which was separating the hot portion from the structural portion, and it worked out well, although this was a lot of time and energy to make this component here, and it worked. I was starting to work out the connection between the firebox and structural elbow, so we can see that how that goes together. I then decided, because these were all being water jet cut, to try and make another elbow just to reduce the kind of complexity of making this part into just a bunch of water jet components. And now this led me to a situation where I've gone from being an independent variable and another independent variable to having 2 more independent variables, which then caused me to have to create ways to manage going between this independent variable to this independent variable to this independent variable to this independent variable. And this became not such a great idea. So I'm going back to this kind of an idea where the structure is separated and it's made out of CNC'd aluminum. This is just a 3D print, but you can see that this component would make it easier for me to rectify this construction where it goes from here to here by just simply having this one part. The next thing we're going to talk about is the pot and the boiler, and how this series of independent variables is going to work with these other set of independent variables to really force this piece to be what it's going to be. Next time I'll talk about these parts that I was making, the next step in producing this thing. All right, that wraps up another episode of Experimental Design, Discourse, and Disclosure. I'm Darren Jackal. I'm in my studio. I talk about product development, design, and mountaineering. Thanks again for stopping by, and we'll see you next time.